Namaste everyone. Let us have a quick review on some of the sample multiple choice questions. Here is the first one. The electric field due to a dipole at any point on the equatorial plane is in the same direction as dipole moment vector, perpendicular to dipole moment vector, opposite to dipole moment vector, and at 45 degrees to the dipole moment vector. So there are four options, and we derive this in a syllabus. The electric field due to a dipole on the equatorial plane. So let us take a charge, two equal and opposite charges separated by a small distance. I will draw an equatorial line on the paper here. And if you try to find out what is the electric field on the equatorial line, this charge will repel it like this, and minus Q will attract that test charge like this. So this is electric field due to plus Q, and this is electric field due to minus Q. Net electric field will come to this direction. And that direction is opposite to dipole moment, because dipole moment is always from minus Q to plus Q. It is in this direction. So this is the direction of dipole moment. So electric field on the equatorial line or equatorial plane is opposite to the dipole moment. Whereas when you find out the electric field, say plus Q and minus Q over an axial line like this, then when you place a test charge here, you know that plus Q will repel it with a stronger force than the minus Q attracting from a far away distance. So this electric field will be stronger. So finally, this is the direction of electric field, which is in the dipole moment direction, which is from minus Q to plus Q. So over the axial line, it is along the direction of dipole moment, whereas on the equatorial plane, it is opposite to the direction of dipole moment. So answer is C. An equivalent unit for volt is, so volt is the SI unit of electric potential, and electric potential is defined as the work done in taking a charge from infinity to a point. So if you want to write the unit for this, you can also have the SI system unit joule per coulomb. So this is the answer, joule per coulomb. Question number 3. A metallic wire of uniform cross-sectional area and resistivity rho and length L is cut into 4 equal pieces of each of length L by 4. Resistivity of each piece is, resistivity is the characteristic of the material. It may change because of temperature, but not because of the length and area. So when a material of uniform cross-sectional area, say a wire, is cut into 4 pieces, the material remains the same, so rho remains the same. Our answer is this one. So rho doesn't change if length changes and area of cross-section changes. It changes when the material changes and the temperature changes. Rho depends only on material and temperature. Okay. Question number 4. Nature of the path followed by a charged particle moving perpendicular to a uniform magnetic field. This is the area where different types of MCQs can be framed. Charged particle is moving perpendicular to a uniform magnetic field. So you know that when the magnetic field is like this, if it is uniform and the charged particle is moving perpendicular to it, then the path is a circle. And if the charged particle is moving along the direction of magnetic field or opposite to it, path is a straight line because it is undeflected. And if the charged particle is moving at an angle to the magnetic field, then the path is a helix. So all the 3 you must know. Okay. Question number 5. Below are the 2 statements regarded to the magnetic field lines. Flux through a closed surface enclosing a magnetic dipole is 0. Yes, it is correct, because magnetic field lines form closed loops. So whatever the number of magnetic field lines come out of the surface, closed surface. So if you have a closed Gaussian surface, then north and south pole dipole magnet is enclosed in. Whatever the field lines come out of the North Pole, they should come into the South Pole. So the net flux through the surface is 0. Magnetic field lines form the closed loop. That is the second statement. Yes, second statement is the correct explanation for the first statement, and first statement is also true. So option A, both statements 1 and 2 are correct. And second is the correct explanation for the first. Okay, 6th one. Motion of a bar magnet induces a current in a coil. As shown in the diagram, the bar magnet is moving towards the coil, away from the coil, or rotating with the like this, with these dotted lines as the axis, or at rest. So what is the answer? You know that here the Lenz's law works out, because Lenz's law says that whenever a magnet moves towards or away from the coil, in order to oppose its motion or cause, an induced current flows. So the induced current is flowing in the clockwise direction here, from the phase where we are observing. It is clockwise, and this turns into a south pole. And if this turns into a south pole, in order to oppose the motion of the magnet, then the motion of the magnet should be like this, because this motion of north pole away, if north pole is moving away, then that is opposed by the south pole by attracting it. Suppose you move the north pole towards the coil, then this should have been the north pole for opposing the motion of the north pole towards the coil. So answer should be moving away, because when the north pole moves away from the coil develops a south pole and opposes the motion of the north pole. So it is according to in accordance with Lenz's law. So the magnet must be moving away from the coil, because this is a south pole. Yes, seventh one. Peak value of alternating EMF in an AC generator depends on. So in an AC generator, the alternating EMF is produced, and among all the individual instantaneous EMF produced, the peak value is EM. We write the equation like this. It is a sinusoidal EMF. The individual instantaneous values vary in the form of a sinusoidal signal. E equal to EM sin omega t. And actually, this EM is from NAB omega. The peak value of EMF is the combination of all these constants. For every cycle, peak value is same. So it is if the number of turns changes, then the peak value of EMF will change. Area of the coil changes, peak value of EMF will change. So magnetic field, then that rotational velocity, that is angular frequency, angular velocity, all these will control the amount of peak value of EMF. So option D. The number of turns in the coil, angular frequency of rotation, area of the coil, strength of the magnetic field between the pole pieces, all of them will decide what is the peak value. Option D. Okay. In an AC circuit containing pure capacitor, current leads the voltage by pi by 2, current lags behind. You know, this is a direct question, because we will be thorough with all the theory here. So you know that in a capacitor, current leads. In an inductor, current lags behind the voltage by pi by 2. So this is for an inductor. And current will be in phase with the voltage for a purely resistor circuit, AC circuit. Okay. Ninth one. So here is the equation. Closed integral of B dot dl is equal to mu naught into conduction current plus mu naught epsilon naught d phi by dt. Okay. So this is the equation. Now, we have this closed integral of B dot dl must be equal to mu naught times the conduction current. This is actually Maxwell's law, only this. Sorry, this is Ampere's rule. And Maxwell found some inconsistency in this, and he added one more current. If that equation has to be perfect, you should add one more current here. This is equation. So totally it is Ampere-Maxwell's rule. So this is only the Ampere's rule. And along with another current, we have Ampere-Maxwell law. A thin concave lens and a thin convex lens having equal focal lengths, okay, equal focal length. So focal length of the concave lens is minus f, convex lens is plus f. You know that it is convex lens in air is a converging lens usually, are kept in contact. Focal length of the combination is, so 1 by f1 plus 1 by f2 is equal to 1 by f. So 1 by f plus 1 by minus f is equal to 1 by f dash. I'll write focal length of the combination. 1 by f plus minus plus 1 by minus f. So that gives 0. So it will be minus f. So 0 is equal to 1 by f dash. That implies f dash is infinity. The thing is, if you incident parallel rays to that combination, they become parallel again. So it is infinity. Oh, this answer is marked. Okay, let's. It's infinity. I have forgotten to remove it. Okay. In the examination, it won't be marked like this. So please note it. Yes, I can remove it here only. Yeah, using eraser. White. Yes. So I can. Yes. It will not be given. Okay. Right. Now, next question. The experiment which confirms the wave nature of light is. So if you want to explain diffraction, you have to consider light as a wave. If you want to explain interference, you have to take light as a wave. If you want to explain photoelectric effect, you have to take light as a particle, quanta, packet of energy. So quantum nature is used in photoelectric effect. So here it is quantum nature of light exhibited. Whereas in Thomas Young's double slit experiment, which explains interference of light, is wave nature. So light is a wave here. Of course, Rutherford's alpha particle scattering experiment, it gives the atomic model. It has nothing to do with light. Atomic model. That experiment confirmed that there should be a nucleus. And Millikan's oil drop experiment, actually Millikan did this experiment, and this experimentally proved the quantization of charge. Experimental proof for quantization of charge. We say that charge on any body is an integral multiple of charge of electron. So Millikan's oil drop experiment confirmed it. Actually, that idea was given by Michael Faraday. So quantization of charge was, that principle was given by Michael Faraday, but experimentally it was confirmed by Millikan, his oil drop experiment. Yes, 12th one. According to particle nature of light, which one of the following statements is true? Photons are deflected by electric and magnetic fields. Photons are not deflected by electric and magnetic fields. So you have to select the true statement. Photons cannot travel through vacuum. Wrong. They can travel through vacuum. Photon energy is independent of intensity of radiation. That is correct, because energy of a photon is decided by frequency or wavelength. It is not decided by the intensity. Photons do not have momentum. No, wrong. They have momentum. So these things are wrong. Only C is correct. According to Rutherford's planetary atom model, the centripetal force for the electron is given by. So according to Rutherford, there should be a nucleus where all the positive charges are concentrated, and electrons are revolving around the nucleus in circular orbits. And if anything has to rotate in a circular orbit, there should be a force which should pull it out towards the center, and we call it a centripetal force. Here, it is the attractional force, electrostatic force of attraction between negatively charged electron and positively charged nucleus. That acts like a centripetal force. So it is the electrostatic force of attraction between the electrons and nucleus gives the centripetal force, and nuclear force between the nucleons that binds the nucleons together and forms a very strong nucleus. Nuclear force has nothing to do with centripetal force. Of course, gravitational force acts as a centripetal force between the planets and the sun and satellites and the earth. That will also act like a centripetal force, but not in this case. So option B. 14th one. The electromagnetic radiation emitted during radioactivity case. Electromagnetic radiation. So during radioactivity, all the things are emitted: alpha ray, beta ray, and gamma ray. Alpha ray is a beam of positively charged helium nucleus, 2He4, and they are positively charged. And beta rays are nothing but electrons, you know that they are negatively charged. Whereas gamma rays are neutral electromagnetic radiation. So answer is D. An intrinsic semiconductor is doped with the trivalent dopant atoms. Now the resulting extrinsic semiconductor is electrically positively charged, negatively charged, neutral, positive or negative charge depending on the number of dopant atoms. So when you take a pure intrinsic semiconductor, you know that it is electrically neutral because the number of electrons and protons are same. You know that in each atom is electrically neutral. Now, it is doped with the trivalent atom means, suppose you are adding boron. You are adding full boron atom. That means it is electrically neutral boron atom. But unfortunately, boron atom has got only 3 valence electrons, and a semiconductor is tetravalent. It needs 4 valence electrons. Boron has only 3 valence electrons, so it cannot fulfill all the bonds. So one bond is left vacant. That doesn't mean that one electron is removed. There is a necessity of one electron. There is a need of one electron, but no deficiency of electrons is created there. So we add the full atom. It is electrically neutral. We show the, so here is actually the extrinsic semiconductor generated is a p-type semiconductor, and it has holes. We indicate it like this. That doesn't mean that it is positively charged. It is neutral. It is electrically neutral because we add boron atom, which is already electrically neutral. So it has nothing to do with charge. So even p-type semiconductor, n-type semiconductor, intrinsic semiconductor, everything is electrically neutral. So there is no charge for it. Okay. So fill in the blanks. Parallel currents dash each other. Parallel current means they are referring to two current carrying conductors placed side by side like this. Two conductors carrying current in the same directions, they attract each other. You know it. They attract each other. Whereas, so we say that like currents attract, unlike currents repel. So if you have two conductors carrying current in the opposite direction, they repel. Current flowing in a coil due to changing magnetic flux is, that is electromagnetic induction, it is called induced current. So this one, induced current. Change in magnetic flux induces a current called induced current. Light is a dash wave because it can be polarized, so it should be transverse. Any transverse wave will show polarization. If a wave shows polarization, then it should be transverse in nature. So transverse is over, then induced is over. Okay. Isotopes have dash number of neutrons. Of course, isotopes have equal number of protons, different number of different mass number. That means different number of neutrons, different. So it is different. Intrinsic semiconductors have equal number of electrons and holes. Yes. Well, yes. So that's all the questions in the sample paper 1. Thank you for listening to me. Thank you.